So what we've done is take Google's big comprehensive AI course, like 4 hours long, and really boiled it down. We've pulled out the core concepts you actually need to get the basics, all in, roughly 10 minutes.
Hopefully bring some surprising clarity.
That's the plan.
And one of the first big things, I think, from that course is realizing that AI isn't just one single thing. It's a huge field of study, kind of like how biology covers loads of different areas.
Okay, so AI is the big umbrella, like biology.
Precisely. And then machine learning fits within that. It's a specific approach inside AI. So if AI is biology, machine learning is maybe like zoology, a branch within it.
Right. Zoology within biology makes sense. So what's the next step down? Is there another layer?
There is. Deep learning. That's an even further specialization, this time within machine learning. So sticking with the analogy, maybe that's like mammalogy within zoology, focusing even tighter.
Okay. AI, machine learning, deep learning. Got it.
And then even within deep learning, you start seeing things like generative models and discriminative models. And this is kind of key.
Yeah.
A lot of the really cutting edge stuff we see now, it sits right where generative models meet something called large language models, LLMs.
Ah, okay. So that intersection, generative models and these LLMs, that's what powers the tools we hear about all the time, like ChatGPT. Or Google Bard.
Exactly. That's where they live, technologically speaking. It helps to see that structure, right? How it all fits together.
It really does. So let's maybe zoom back in on machine learning for a sec. What's the core idea there?
Sure. At its heart, machine learning is about creating programs that actually learn from data you feed them. Input data.
Okay, they learn from data.
Right. And through that learning process, they train up what's called a model. And that model can then make predictions or, decisions when it sees new data it hasn't encountered before.
Right. Like the example they used, predicting Nike or Adidas sales based on past sales data.
Yeah, something like that. You train it on historical sales figures, features of the shoes, market stuff, and then hopefully it can predict how a new shoe might do, identifying patterns to guess the future, basically.
Okay. And the course talked about two main ways this learning happens, supervised and unsupervised.
That's right. And the big difference really comes down to the data you use for training, specifically whether it has labels or not.
Labels. What do you mean by labels?
So supervised learning uses labeled data. Think about training a model to predict if a restaurant tip will be high or low based on the bill. In supervised learning, your training data would have the bill amount and a label saying if the tip was high or low. Or maybe, like in their example, if an order was picked up labeled blue or delivered labeled yellow. The model learns the connection because of those labels.
Gotcha. The labels give it the right answer during training, so it knows what it's aiming for.
Exactly. It compares its predictions to those labels and adjusts itself.
So how does unsupervised learning work then, if there are no labels? What's it learning?
Well, unsupervised learning is more about exploration. It tries to find hidden patterns or natural groupings within data that isn't labeled.
Okay, so finding structure on its own.
Yeah. Imagine you have data on employee tenure and maybe their income, but no labels like male, female, or department. An unsupervised model might look at that data and find natural clusters.
Like groups of employees that look similar based on tenure and income.
Exactly. It might identify a group that seems to be on a fast track, maybe shorter tenure, higher income, without you ever telling it to look for fast track employees. It just finds the inherent structure.
Interesting. So supervised has a target, unsupervised finds its own patterns.
That's the gist of it. And you can see why unsupervised is interesting, right? Labeling massive data sets is expensive and time-consuming.
Yeah, makes sense. Okay, so that's machine learning basics. What about deep learning? What makes it deep?
So deep learning is a type of machine learning, remember, but it uses something specific, artificial neural networks. And these networks have multiple layers stacked on top of each other.
Layers, like layers of processing.
Kind of. It's loosely inspired by how neurons are interconnected in the human brain. You have layers of these nodes or neurons. And generally speaking, the more layers you have, the deeper the network, the more complex patterns and relationships the model can learn from the data.
So more layers often means more powerful models.
Often, yeah. And this architecture, these deep networks, they enable something really useful called semi-supervised learning.
Semi-supervised. Sounds like a mix.
It is. Deep learning models can be really effective when you have only a small amount of labeled data, but a huge amount of unlabeled data.
Oh, okay. How does that work?
Think about, say, bank fraud detection. You might have a relatively small number of transactions definitively labeled as fraudulent or not fraudulent, maybe like 5%.
Right. Labeling takes effort.
Exactly. But you probably have masses, maybe 95% of unlabeled transaction data. A semi-supervised approach uses the deep learning model to learn from that small labeled set, but also leverages the patterns and structures in the massive unlabeled set to improve its overall understanding.
So it gets the best of both worlds, kind of. Uses the little bit of labeled data it has, plus learns general patterns from the rest.
Precisely. Very useful when labels are scarce or costly, like in medical imaging, too.
Gotcha. Now, you mentioned earlier within deep learning there were discriminative and generative models. Can you break those down?
Sure. So discriminative models are mostly focused on learning the boundaries between different classes or categories in labeled data.
Boundaries. Like telling things apart.
Exactly. If you feed it labeled images of cats and dogs, a discriminative model learns to tell the difference. Its job is to look at a new image and classify it. Is this a cat or a dog?
Okay, classification. What about generative models then?
Generative models are different. They try to learn the underlying patterns and distribution of the data itself. They learn what makes a dog look like a dog, 2 ears, 4 legs, barks, that sort of thing.
So they learn the essence of dogness.
Kind of, yeah. And because they learn that underlying pattern, they can then generate new examples that look like the data they were trained on. So a generative model could actually create a new picture of a dog that's never existed before, but still looks realistic.
Wow, okay. So discriminative classifies, generative creates.
That's a good way to put it. And a simple sort of test. If the AI's output is a number or a classification label or maybe a probability score, it's probably not generative AI.
Right.
But if the output is, natural language text or an image or audio, something complex and creative, then it's likely generative.
And we're seeing tons of those now, right?
Oh, yeah. Text to text, like ChatGPT and Bard. Text to image Midjourney, DALL-E, Stable Diffusion, and they can even edit images now.
Editing too, yeah.
Yep. Then there's text to video, like Imagen Video or Make a Video, again with editing. Text to 3D models like Shapey, used for maybe making game assets. And even text to task, where you tell an AI like Bard to do something specific like summarize my latest emails.
That's a huge range of capabilities. Amazing how fast it's moving. Okay, let's pivot slightly to large language models, LLMs. The core stress they've heard of deep learning, but not all generative AI is an LLM. What's the key thing about LLMs?
Yeah, that's an important distinction. The really defining thing about LLMs is how they're trained. It's typically a 2-stage process.
2 stages.
First, there's extensive pre-training. They get trained on absolutely massive data sets, like huge chunks of the internet, books, articles. This gives them a really broad general understanding of language, grammar, facts, reasoning abilities, etc.
So that's stage 1, broad general knowledge.
Right. Then comes stage 2. Fine-tuning. After the general pre-training, they're trained again, but this time on much smaller, more specific data sets tailored to a particular task or industry.
Okay. So like they learn general English first, then learn medical English specifically.
Exactly. The analogy they sometimes use is like training a dog. The pre-training is like teaching a puppy basic commands, making it a good general dog.
Okay.
Then the fine-tuning is like taking that generally trained dog and specifically training it to be a police dog or a guide dog or a hunting dog, specializing it.
That's a great analogy. Pre-trained generalist, fine-tuned specialist.
Precisely. And those pre-training tasks are things like, predicting the next word in a sentence, filling in blanks, answering questions, summarizing text things that build that core language understanding.
Right. And then the fine-tuning uses specific data.
Yeah. Industry-specific data sets. So a retail company might fine-tune an LLM on its product descriptions and customer reviews. A finance firm might use market reports. Healthcare might use medical journals and anonymized patient records.
Like the hospital example you mentioned, taking a general LLM and fine-tuning it with their specific medical data and research to get better at reading X-rays.
Exactly that scenario. The general model provides the foundation, the fine-tuning provides the specialized expertise.
It seems like a really efficient model development-wise.
It really is. You have these, big tech companies often developing the massive, expensive to train general pre-trained models.
Right.
And then smaller companies or specific departments can take those powerful general models and fine-tune them relatively quickly and cheaply with their own specific data to solve their specific problems. It's kind of a win-win.
That makes a lot of sense. Well, hopefully this quick run-through of the key concepts from Google's course has helped clear things up a bit.
Yeah, giving folks a clearer map of the AI landscape, how AI, ML, DL, generative AI, LLMs, how they all kind of relate to each other.
Exactly. You should now have a much better foundational understanding, which hopefully makes navigating all the AI tools and news out there feel a little less daunting.
Definitely. And thinking about that fine-tuning piece, it really makes you wonder, doesn't it? Given how LLMs are being specialized across so many different areas, what are some of the really unexpected, maybe niche applications we might see emerge soon? Things tailored to very specific needs or domains we haven't even thought of yet.
That's a great thought to leave people with. What are those next specialized uses? Interesting. Okay, well, this discussion is part of Le Podcast de Philippe.
And if you found this deep dive helpful, if it cleared some things up for you and you want to support us making more content like this,
please do head over to YouTube and help us reach our goal of 1,000 subscribers today. We'd really appreciate it.